2, 3, 4. My students don't mess around because they love me so. This I know for sure. But when I tell them to go home and watch the nurses, they'll say no. I can't believe I gotta sing this dumb song and make it exciting. Just to take your notes because it is gonna make you so much smarter. Hey, Ma. Hey, math. Hey, math. Wow, that was good. Thanks for stopping by, Outcast, and help me sing the song to these guys. Alright, well, 6-5. We were going to have the trig form of a complex number, so we're going to add a couple of your favorite things, i's and j's, and trig. It's going to be such a great time. Alright, the first thing we need to talk about is how to represent a complex number. So a complex number is where you have imaginary roots. Here we're going to say z is equal to a plus bi. So if that's how we represent a complex number, AB is in your coordinate plane, we call it your complex plane. Your horizontal axis is your real axis. So anything that is an A value, you're going to graph on your horizontal axis, your real axis. And your vertical axis is what we're going to call our imaginary axis. So if you notice the point, or the equation down here, the expression down here, 3 plus 2i, notice how 3 is your real part, 2 is your imaginary part. Well, that is a point if you go 3 on the real axis and up 2 on your imaginary axis. So you get this point. If you have a -1, 3, well, -1 is your real part, so you go back 1, and then 3 is your imaginary, which means you just go up 3 and put your dot. So that's how you plot points on your complex plane. So if we have a complex number of or an absolute value of a complex number, a plus bi, is your distance. Anytime you talk about absolute value, that's going to be your distance from your origin. And the way to find your absolute value is to take the square root of a squared plus b squared. Oh my gosh, it's just like the Pythagorean theorem all over again and again and again. So if we need to plot, for example, 1, we need to find our absolute value and we need to plot this equation. We're going to have z equals 3 minus 4i, and that is 3 on your real part. So we're going to go 3 to the right, and then we need to go down 4 because that's -4 on your imaginary axis. So we're going to have this point down here. This is where you get a 3, comma, -4. So then to find the absolute value of z, what we're going to do here is just find the square root of that ordered pair. So we're going to say 3 squared plus -4 squared. So I have a square root of 3 squared is 9 plus 16. Don't forget that's a -4 squared is always positive. So you get a radical 25, which is a 5. Now what that means is this point is a distance of 5 from your origin. So if you have a point from, or if you have the distance, if you were to draw a line from your origin down to your point, that would be a distance of 5. And that's how you're going to plot a complex number and find its absolute value. Hey, 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 math.